So here we go. Hello, Meryem. How are you?
I'm good. How are you doing, Jeremy?
I'm good. I'm good. Thank you. I'm really glad to have you here today because, as you know, we've talked before, I've followed what you're doing on LinkedIn. I think what you're doing and the purpose of your company, everything you do around AI is really needed right now. So I'm really keen on deep diving and having a free flow conversation, as I'm currently doing with everyone that I try to invite on this podcast. It's really supposed to be a chill conversation. It's only three questions: your story, your mission and drive, your vision of the future. Only around those three questions, we're going to go for 25, 30 minutes, whatever it maybe like 40. Let's see how it goes. But essentially, I want to like encourage you to open up as much as you can on everything, because it's like I really like find those moments with everyone that I interview super enriching, and having the ability to just not be confined to like questions and answer and question and answer can allow us to go sideways and see how a random conversation can go, basically. So if you're good with that, let's get started. Are you good?
Oh, yeah, let's go.
Cool. So who are you, Marianne? Can you present yourself?
So I'm Meryem Arik. I'm the co-founder and CEO of TitanML. TitanML is an LLM ops company. We help businesses build and deploy generative AI within their own secure environment, so on-prem or virtual private cloud environments.
Hmm. Great. How long have you been doing that?
So we've been doing this for a couple of years now, since before ChatGPT came out. So we're one of the OGs.
Mhm.
We were working
Okay.
on deep learning more generally, specifically around how we can make deep learning inference more efficient. So we started working in computer vision, and then we moved on to like BERT style language models, and have been working on generative models ever since the end of 21. No, ever since the end of 22. Um,
Nice.
but the reason we started the company was we realized that deep learning, firstly, would be a huge industry, and that the biggest bottleneck in deep learning, if it was really going to reach its potential, would be the inference stage. And that's when we started working with my co-founders on how we can make that inference stage as efficient as possible. And that's what we've been doing ever since.
Okay, cool. And for just for the purpose of like generalizing and having the max like the minimum jargon, what is an inference? When we're talking about AI and API, what is inference?
Sure. So we can kind of distinguish running AI models into two stages. We have the training stage where the model learns all of the things from the data. And
Hmm.
then we have the inference stage where it actually starts making predictions and making generations. So that training stage you typically don't see. It's typically done, especially with LLMs and the big hyperscalers like OpenAI and
Mm.
Google. But the bit that you actually see is the inference stage. So, for example, if you're chatting with GPT and it's giving you answers, what it's doing is inferencing. It's inferencing your message and giving you out results. So, whenever you interact with a LLM or AI model, normally you're normally interacting with it in the inference stage.
All right. Yeah. So basically, we take the word data, we put it into big scalers, big machines that make calculation, combine it to a file of ones and zeros. And when this thing is called, it's the inference, and this is what you're working on to make
Exactly.
that the most like efficient as possible, basically.
Exactly. Now,
Excellent.
like you might think that the training part is the most energy intensive part of the process, and it is really, really energy intensive. However, training is only done a couple times. So you might need to do, let's say, 10 training runs to be able to get a model out of it.
Yeah.
So
Okay.
per run, it's definitely more energy intensive. However, the inference stage happens so often, constantly. Imagine every single time you call ChatGPT, and happens for years and years and years and years. Over the lifetime, the cost and the emissions and the energy consumed during the inference stage is really considerable.
Yeah, I can imagine that. And that's a big topic. Like a lot of people now are kind of raising their awareness on, wait, like how different is this from the previous software paradigm? Because when we had software like Web 2 or like with like basic SaaS software, you had the cost of a server, and that's it. You don't have dependencies at every call. You have a new token calculation. You have like all that stuff. This is something that people don't really realize, but it's a completely different cost structure, and also completely different way to operate this kind of software. And I really appreciate like the fact that there is like companies like you guys who are working on that part, because right now it seems like the only holy OpenAI is the one that has all the like the knowledge, resources, and capabilities with along with Microsoft and the big guys. So, like, can you tell me more about the origin story, probably of the company, probably of like even a bit more back in the history of you and how you came to that position? Like, how were you as a child? Were you already like a curious child going on? How were you? Like, let me like understand, where does this come from? Why are you here?
It's a really good question. And you might need to ask either my parents or a therapist about all of that. But the so I'm very fortunate to come from a really fantastic family, a very loving family. I've always been very curious. I think I was a pretty annoying child, asking why,
Yeah,
constantly
I
asking
was that kind
questions.
of child too, so I get that.
Yeah, I mean, I feel for our parents, but it's better than a child that doesn't say anything at all.
Yeah.
Um, and I was always just interested in things, whatever those things might be. Like I remember, I would always be super interested when my mum, for example, went to the butchers I would look at like the fish heads of the fish that were cut off, and I'm like, oh, I wonder like how they see, and trying to figure out
Mm,
all of these things. So I was
okay.
always a really, really curious child. Um, and I had a big turning point when I was about 12 ish, um, which is, I think two major things happened when I was about 12 that kind of led me to where I am now. So the first one is that I thought I wasn't good at maths and physics, which is really interesting. And the
Okay.
reason I thought I wasn't good at maths and physics is because I think I thought it was uncool. Um, and my parents said, okay, well, if you get the top grade in maths and physics, I'll buy you a dog. And
Oh.
all of a sudden, overnight, I became one of the best in the class in maths and physics, and ended up by going to university to study physics. And it was like this big kickstart that I needed to realize, oh, all of this curiosity that I had actually is really useful in my academic life as well.
Nice.
So when I was about
Uh,
12 or 13, my academic kind of results really, really changed. And then secondly, when I was 12 or 13, my father started his startup, his company, which is still going on to this day.
okay,
And
cool.
yeah, so I'm from a family of entrepreneurs. So from
Nice.
about that age, firstly, I took my academics more seriously. And then secondly, all of my dinner time conversations were about startups and about building a company. And I think
Cool.
that really impacted where I have ended up now, where I did super well academically, and then also have always had this interest in building things and creating things that didn't exist before.
Nice. Building something new, like keep
Exactly.
building on top of what we have to improve it and stuff, is super like inspiring. I agree with you. And yeah, that's amazing. So you're very lucky to have like a dad that is already entrepreneurial. Like for me, it was super hard to like even make them understand that I was starting a company. Like I was in the corporate world, I was doing the finance guy, working for executives. Everything went well, and someday I decided to just say, okay, drop, I'll move to like fixing problem from the outside. And so I really like kind of relate on this thing about like having someone close by that you can have that can help you out and where you can discuss and have this kind of conversation might have been super helpful to to
Yeah,
to to go where you are now.
it really, really was. And I think there's a few things that it taught me. So my parents have never have always encouraged me to be able to fail at things. And when I said, we were going to start this company, we're going to go down this route, we were warned about how difficult the road is and how it's a really difficult challenge. But that failure was never seen as something bad. It was always seen as like a huge learning opportunity, and an amazing experience. So I'm incredibly lucky to have parents that are really supportive of me. And I'm also really lucky to be able to, have had a good education and live in a country where even if it doesn't work out, I know I'm fine. I can just get a job somewhere else. So I think that is a series of really fortunate events for me that not everyone has.
Yeah, exactly. We need to. I think it's really wise to be able to like see this and be grateful for this and be like, yeah, that's why I'm fortunate. I have all the keys now. I'm gonna do the work so that others can like benefit from that. So I guess it's really like it's really cool to see that in you. Tell me more. Like, okay, so you were good at academics. You wanted to do like entrepreneurship because it was like something that already was kind of built into you. And how did you meet your co-founders? How did you came into the subject of AI and ML? It might have been many different physics topics, and you ended up in data and AI. So why?
Yeah, so it's actually a pretty roundabout story. I wouldn't say that I wanted to be an entrepreneur. Like I wasn't one of those people that when I graduated, I'm like, I need to start a company. In fact, because I had seen how hard it was, I really didn't want to do it unless I thought I really had an edge and a way to really make something fantastic.
Mm-hmm.
So when I graduated uni, I did theoretical physics and philosophy, which is a great degree. I didn't really know what I wanted to do when I was 21, 22. So I went into the corporate world. I became an investment banker, which I actually really, really loved because I was learning a bunch and I like anything where I'm continuously learning.
Mm-hmm.
Simultaneously to that, my two co-founders, who are also physicists by background, were doing their PhDs and postdocs. So I was in the corporate world. I then very quickly realized I had a startup itch, so there's them working in a startup while they were working in research, and we were, kind of knew each other from our uni days, and they were working on interesting research methods that would make deep learning models much more efficient. This was research that was inspired by their work in quantum computing. And we kind of came together and started exploring commercial opportunities. Initially, it started as a research project, but then it turned into, it being a real commercial opportunity. And for
That's
me,
great.
my intentions as like a founder, I didn't want to be a founder particularly, unless I felt like I had a really valuable idea that it needs to be built. And that's where we found ourselves in 22.
Cool. And so 2022. So it was like, I remember when I first heard about Transformers, it was around that time, I guess. 20, even 2020, we had Transformers
Yeah,
came
so
out. When?
Transformers came out 17, I
Oh,
think,
yeah.
17, 18. And then we were working with them in computer vision and then in BERT models. We were doing a lot of encoder style models in 2022. So yeah,
Okay.
that's when we were
Yeah.
working there.
Long way until like the big wave of ChatGPT, right?
Yeah, I mean, it was and it wasn't. So um, I was first exposed to generative AI, as in like the current, generative
The current
transformers
state.
that we
Yeah.
see, with GPT-2, which came out, test of my knowledge, maybe 2020, potentially before that. I don't know.
Yeah, maybe. Yeah.
Um, and it was surprisingly good. And as soon as GPT-3 came out, GPT-3 was really, really good. So if you were following it from GPT-2 to GPT-3, you could see such a big jump that it seemed kind of not obvious, but likely that would be able to create something as amazing as ChatGPT. I think what I got wrong and what we underestimated is the pace at which this would happen. We always knew that this kind of conversational AI would be huge, but we didn't necessarily know it would come as quickly as it did.
I get that, yeah. And but even for them, if you think about it, like the OpenAI team, they were not supposed to launch that as a major product. They were just like, it was a research interface at the beginning. That's how they framed it, at least.
I don't know if I believe that.
Aha, interesting. Because they were having all the because what? Because they were already having all the organization attached to it. Like they were already organized to deliver that stuff.
Well, I think it's ChatGPT is the most phenomenal way to collect training data. And given how important training data is in training better models, it's essentially just a function of training data and compute. That like it seems really obvious you would want to get feedback. So I agree they probably didn't expect it to be this huge kind of commercial success maybe, but they definitely wanted a lot of people to be using it in anger because that's how they get the real benefit.
Cool angle. All right. Yeah, because the people have been talking about it without really putting some really concrete ideas around it. So I want to deep dive in this because it's part of, I think it's part also of the question about your mission of not being so locked in with the system that eventually will use your data to build powerful system that will be the byproduct of your own intelligence, essentially, but will not be owned by you. So yeah, I find this idea very interesting because also myself, I always try to like put that into perspective coming from finance, as you also come from. You know, when you see the big balance sheet of the like Google and Amazon and everything, the balance sheet, their wealth is made out of the data that they collect out of us as in companies, individuals. So the money that we don't have in our pocket because they use it, it's actually in their balance sheet, right? So because they accumulate the intelligence that we don't accumulate for us, and our computer is still a mess. Like the way we organize our data is still a mess. They do stuff in a certain way that like they organize, they collect, they store the data so that they can reuse it and make sense of it and make money out of it. So like for me, it's really a good like topic to deep dive on, to think about what those guys are building in terms of infrastructure and how many researchers they put, and like, can you talk about that versus what is needed if you want to have a complete alternative to that, which is what you're building, if I understood correctly, and like what are the pros and cons of those two things, and like what's your drive on building that stuff? Like I think you already touched the drive that you have, but can you like deep dive on that and like try to do a balancing act of what's good, what's not? And it's interesting to deep dive.
So broadly, there's two ways that you can deploy a LLM or a generative AI application. One way is you can use an API-based model like OpenAI or like Anthropic. And in that case, it's actually really easy to work with. You essentially just, you know, if you know how to use an API, then you're done, and you can start inferencing with this model, and that's fantastic. Now, the upsides of this is like the model qualities tend to be really good. It's very, very easy. The downsides, however, is it's less scalable. You might have to think about rate limiting. You definitely want to be thinking about having more interoperability or more diverse vendor types. You get vendor lock-in. There's issues around latency and cost. So there's definitely upsides to using these API-based models, but there's also some downsides. Now, the alternative to using these API-based models is what we call self-hosting models. So this is when you use an open source model like a Llama or a Mistral or a Mixtral or a Falcon or something like that, and you actually deploy it within your own environment. So whether that's your own cloud, your own VPC, or your on-prem data center. Now, the benefits of these are considerable. It's essentially the inverse of all of the negatives. So hugely scalable. So it's great if you're building like an enterprise scale application, much faster, much cheaper. You get real control over your models, so you can specialize them for your needs. And it's a much nicer ecosystem to
Yeah,
build enterprise
especially
applications.
in this area where we are talking about having language model very specialized on tasks and where they're performing
Exactly. And when they're really specialized, they're much, much better. But the downside of this is it's much harder to build with these self-hosted models. Now, the reason it's hard to build with is because OpenAI and these API-based providers have built loads of infrastructure that you don't see, whereas when you're self-hosting, you have to build it yourself. So Clem, the CEO of Hugging Face, who's one of my
Hugging Face.
favorite people to follow. If you don't follow him, you should. And
Yeah,
the Hugging Face team.
of course.
He described comparing an open source model with an API based model as comparing an engine and a car, right?
Yeah,
So
I follow that too completely.
Yeah, so OpenAI has built this engine, which is their core model, but then they built all of this infrastructure around it. The most importantly, their inference server, controllers, batching servers, all of these things. Whereas when you have your engine and your raw model, you've got to build that car around you. So what we do at TitanML is we provide that car that you can wrap your engine around, and then you can use that self-hosted model with all of the infrastructure pre-built around it to build great applications. So you can focus on building great applications and your data and not worry about the model. So essentially, we provide all of that infrastructure that you get for free with OpenAI or take for granted with OpenAI that you would otherwise have to build yourself if you were self-hosting.
So there is a foundation model made by the labs, and you are kind of the. I often take the pharmaceutical industry allegory where you have the labs and the wholesalers and the pharmacists and all that stuff. So you're at the packaging level, at the shell level. You provide a shell around the raw material so it can be consumed basically by and yeah.
Yeah, so our thesis is that we will not be able to build applications as well as the enterprises themselves, as well as the data science teams themselves. But what we are really, really good at is building infrastructure. So we build all of the infrastructure to make building scalable, robust, enterprise secure applications as easy as possible. So that kind of final layer of, doing things like data and prompting can be done by our users, but we provide that toolkit that you need.
Yeah, because there is different layers of prompting, right? From a foundational model, you might have different layers, and because like literally when we are using ChatGPT, we are interfaced with so many different layers of prompting, right? It's like that are redirected, and this is the part that you say that we don't see.
Yeah, exactly. There's so much that you don't see happening behind the scenes. I mean, they have teams of dozens and dozens of incredibly accomplished engineers working on just the inference server that we work on, and that's just not something that can be recreated in every single enterprise that wants to self-host language models.
So let me ask you a complicated question. I think the generative word is not good because it's not generating anything. You can actually like, how much can you predict the next word? Like, can you literally like tweak the inference so it can turn phrases differently at the very very small layers? Like, I don't know if my question is clear, but basically, I've heard a lot about like we don't know how this thing it magically come out, but actually, how much can you like constrain the model to split like text in a certain way?
It's a fantastic question, and constraint generation is something that our clients care a lot about. So, one of the big use cases that we see all of the time is around users wanting to output JSON or regex or something. And it's very difficult to get your model to very reliably output JSON or regex just through prompting. So there are things you can do on the model layer. So if you go down into the actual model, where you can constrain with 100% certainty that this model will always output JSON or will always output whatever schema it is that you care about. And that's something that our clients find incredibly useful, because you then get that reliability. Now, I can't promise that the output that it produces is correct, but it will definitely be in that JSON schema that you care about, and
So
you're
it's
able
more
to do
about the
that correctly.
format that you can be sure of.
Yes, exactly. Exactly.
Good.
You're also able to do like word level and token level constraining as well. But the use cases that it's a bit more complicated, and the use cases there are less clear.
Maybe it
But we're
implies retraining also and having your own data fed into it.
It actually doesn't, because what you change is you change the logics. So it happens within the model itself. So you
Mm.
don't need to, for example, if I only wanted my model to say the token for example, I
Yeah.
could constrain my model such that it could only see that in the probability distribution and can't say
Okay.
anything. So there's things you can do on kind of the model level when you have control of the inference server, like our clients would when working with us, that they can constrain the generation so it fits with whatever they expect to see.
Super interesting. So basically, you get all the capability of constraining foundation models through your infrastructure shell, let's say, you can
Mm-hmm.
bring around, so that basically now people can come with their own data pipelines and also their own
Exactly.
interfaces.
Exactly. Because one of the most common use cases that we see for using LLMs in enterprise is around document processing as an issue. So they want to be able to take a PDF or take a contract and return structured JSON of the main points in that contract and put that in a
Mm-hmm.
database. Now,
Mm-hmm.
if you don't reliably generate JSON, then if you put it in your pipelines, it's going to break occasionally.
Yes.
So that's like a use case we see a lot.
Okay. Great. And I have like probably what's coming to my head right now is like, can we talk about like the difference between like having this sort of infrastructure to run your LLM, your foundation AI models, and the necessity of building some kind of knowledge base or knowledge graph or retrieval of document, like how does this fit together in your picture? Because it sounds like it's an important part of the whole picture in which you play like a role, but I'm not sure, like probably like this needs to be clarified.
it's it's absolutely a very, very important role. Being able to put in your own documents and proprietary information are absolutely crucial for building defensible and relevant AI applications.
Yeah.
So a very common pattern that we see is this RAG pattern, the retrieval augmented generation, when you attach a vector database with your own documents in it. So we recently released Takeoff RAG engine, which uses the
Oh.
Takeoff inference server inside, but it's all of the key infrastructure that you need to be able to build a RAG pipeline.
Okay.
And what the users then focus on, or the developers then focus on, is the data that I need and maybe the front end that I need. But all of that infrastructure is already taken care of. And we built that because it's just such a common pattern that we see with Takeoff.
Cool. Cool. It's a very promising like area, right? It's like you in where do you see all this going? Like, do you have any vision of like the future where? So obviously, from what I've learned from you now, you're like, we need an alternative to OpenAI private API stuff. That's for sure, and I really believe that it's definitely needed to build alternatives to to the big faceless tech companies. Um, but like, is there anything else that that kind of triggers you, or that you want to impact, or anything that can be basically the your picture, your visualization of the future? Where do you want to play your role? And yeah, I'm curious to learn more about that.
Yeah, I'm incredibly excited by the market that we're in right now, and I'm
Yeah,
incredibly
me too.
excited by the opportunities for the space we're working in. We've seen over the last year people doing a lot of proof of concepts with AI, specifically with APIs normally and getting fantastic results that are genuinely bringing business value. This isn't a hype cycle. This is genuine business value that is being generated. Now, what I'm really excited by is over the next couple of years, we're going to be seeing the productionization of all of these projects and all of these ideas. And these things are going to go into production normally in a self-hosted manner. So normally in their own virtual private clouds or in their on-prem data centers. And, I called 2024 the year of the self-hosted LLM because I think this year we're going to see huge strides in open source technology when it comes to open source language models. Mark Zuckerberg has already announced a huge cluster that will be used to train the future generations of llama models. So I'm incredibly optimistic about the space that we're in and where we sit in that space. So it's going to be a good couple of years.
Yeah. And how about like making sure that we ensure like fair distribution of the business value generated by that? Like you were talking about ecological costs, but what's your thoughts on that?
It's a hard question and one that I've kind of grappled with.
Yeah, I
It's
imagine.
it's not a simple question to be able to figure out. But what is really clear is that we need radical and rapid action by our policymakers and our decision makers there to ensure that we don't sleepwalk into a fairly dystopian future. If AI goes the way that some are predicting, and I can see potential for that, we could see mass, like 10 to 20% systemic unemployment or underemployment of people. And that will have huge ramifications on us as a society. You aren't able to function, have a successful society with 10 to 20% of unemployment. So I think our policymakers need to be radical and realize that this is a real kind of almost emergency situation that we need to be able to address and readdress the way that we think about these things.
So you believe in regulation? You think it's needed?
Yeah, well, I don't necessarily know if regulation is the right word, but we definitely need action by our policymakers. Maybe that's a slightly different social construct that we need, or
to that extent, you mean?
Yeah, I mean potentially, because if we're looking at a situation where we're going to have phenomenally intelligent beings that are essentially free, right? That are essentially free, then a large proportion of the work in the economy changes, and change in the past has been fine because it's happened over a long enough period that people can adapt and move and retrain. But if we're thinking that this change is going to happen in the next 3 to 5 years, that is a really short period of time, and that's not enough time for our policymakers to act. So I think we need to be thinking really radically.
That's amazing. Like the radical aspect of things, I completely buy into this. It needs to be opinionated, but I personally, I want, like, my personal vision of this is like we need to enable anyone to have their own AI avatar, kind of navigating the digital like realm and taking care of the data of all the digital interactions. And I think that what you're doing can help basically anyone that has some kind of infrastructure, because also the hardware can go down to smaller sizes. So tomorrow, what about going into some kind of Raspberry Pi or small computer where your software can be in there and probably like, I don't know, but there's also this guy in the Silicon Valley who is doing like tiny corp. I don't know if you've heard about that guy. He wants to create like very small like device you can, like hardware you can plug to anywhere, and it will continuously retrain on your data. It's tiny corp. I don't know. He's done a Lex Friedman podcast. This guy, I've been like amazed by it.
I mean, I've seen there's a lot of these kind of ideas coming out of Silicon Valley, like there's the rabbit thing and all of that. So yeah, it's definitely going to be an interesting couple of years, and it's I mean, I'm not very optimistic that our policymakers will do anything. For example, we've known about climate change for absolutely decades and done very little about that.
Yeah.
I'm not entirely hopeful that we'll do something about AI, even though it's going to come very, very quickly as well. So I think we need radical change, and I'm not sure that our systems are set up to deliver it.
Yeah, so that's why I think us entrepreneurs, we need to make our own calling and for fairness, and try always to think about the bigger picture than just like the narrow like corps that we may serve, or organization that we may serve. It's like it needs to be whatever we do, we need to have a bigger mission. And I think that you what you're telling when you're like basically sharing about your journey and what you want to provide as an alternative to the big like API package stuff versus your way of doing is definitely going in the right direction. And I'm really grateful that there's people in the world that do that like you. So uh, cool. All right. I think it's a good way to wrap this up, Meryem. We've talked about everything that I hope we could like discuss. We talked about you. We talked about your story, about what you're doing, about where you see things going. It's been a very insightful conversation. So thank you. I hope that like things will go wonderful for you guys. You're already doing amazing. So keep building, and we'll see you around. Uh,
Amazing.
where should we like follow you, or what's the best place to keep in touch with you?
So I'm most active on LinkedIn, so follow me. My name's Meryem Arik, and then also follow TitanML on LinkedIn as well. We post some pretty good content.
Cool. All right. Thank you so much, Meryem. Have a
Thank you
good
so
one.
much.
See you.
Bye.
Bye.